Alright, crew. This is a very short, unedited video on the rational root theorem. So, what is the rational root theorem? Well, you know that sometimes you're going to be asked to factor polynomials that look like this, right? And this one you're so familiar with that you could probably do it just off the top of your head. Now, if I told you to find the roots to solve this function, polynomial function, by finding all of the roots of this, you could probably do it just by factoring, in that you would set a y equal to 0, and then if the two things are multiplying to 0, then at least one of them has to equal 0, so you know that this is why I set each factor equal to 0. And so, okay, I have found the roots, and in fact a very special kind of root, which is considered a double root, or a multiplicity of 2, right? These mean the same thing. Okay, so what happens if I give you a polynomial that I can't factor? Let's say this guy. And I went ahead and set the function equal to 0, and I told you to go ahead and solve and find all of the roots. Well, you probably wouldn't know how to factor this, and that is because pretty impossible to factor this. So in fact, we've come up with a way of guessing and checking that's a little bit smarter than just guessing all of the numbers in the world. So how am I gonna guess some smart numbers in order to see if these guys are roots for this polynomial function? Well, what I'm going to do is I'm going to take the constant term. This you'll see a lot on your test. You'll see like a p equals, and then I'll give you a blank. So I'm going to take the constant term, and I'm going to take the factors, all of the factors of that term. And then I'm going to take the leading coefficient, and I'm going to write down all of the factors of that. Well, that's just plus or minus 1, right? Notice that I also labeled them P and Q. This is the P over Q that you see a lot on your papers, that some of y'all are still missing. And what you're going to do is you're going to take every single P, factor of P, and divide it by every single factor of Q. Well, you can see that after I simplify that, it's really just all of the p's written all over again, right? Sometimes, though, you may have another number in front of here, let's say 2, in which case you would write plus or minus 2, and then you would have to go and take all of these guys again and write them over 2, and all 4 of these would be all of our guesses. All of our options for our guesses. But I don't have a 2 in front of here, so right now I'm stuck with really only guessing positive 1, positive 3, negative 1, and negative 3. Now notice how I do have that plus or minus. Some of you are still missing those on your papers. That plus or minus is there because how can I get positive 3? Well, it could be plus 1 times plus 3, or it could be minus 1 times minus 3. I don't know. So there is our guesses. So I'm going to start from that bank of guesses. Guessing and checking, plugging into my polynomial and seeing if that is a root. Well, how am I going to do that? Well, synthetic division is a quick way of doing that. My original polynomial was x to the 4th minus 4x squared plus 3. Now, if you recall from our synthetic division video, that if after I did synthetic division, let's see, making sure to put in my placeholders, if I got a remainder of 0, then I knew that this number was a root for that polynomial. We phrased it earlier as I would have known that this guy, the corresponding factor to that root, would actually be a factor if the remainder is 0. right? So I'm going to go ahead and I'm going to check if that root really is a root to this polynomial. So I'm going to bring down the 1, and if you want a clear review of synthetic division, there's a synthetic division video under semester 1, unit 6. Hey, the remainder is 0, which means that 1 is a root to that polynomial. What does that mean? Well, that means that if I was graphing a polynomial function that looked like this, at 1, this polynomial function would actually cross the x-axis. Alright, well you guys know that sometimes it could bounce off of this x-axis, and I call that a double root. So I have to check, is 1 a double root? Is this like one of those roots that happen to be a special coincidence where, you know, it works twice? So let's check. Now, is 1 a double root? Okay, so I'm going to try it again, but this time, since I've already factored out a root, I can reuse the coefficients that are here. Why? Technically what I've done is I have taken out a factor of x minus 1, remember there was a corresponding factor to that root, and I have now reduced this polynomial to x cubed plus x squared minus 3x minus 3. So now my new coefficients are this new lineup. Again, for a review of synthetic division, there's a good video in Unit 6. Okay, so I'm going to try 1 again and see if it is indeed a double root. Oh. Is it a double root? No, it does not work twice. But the good news is, I still have a nice factored out polynomial where I can go and try another guess. Now, my guesses were pretty limited. I've already exhausted plus 1. I already know it works once and only once. So now I'm going to guess something else. So, let's guess negative 1. Again, I'm going to do it with the nice lineup, the last one I know to have worked. Hey, so indeed, negative 1 is the root of that polynomial, which means that it, oh, I guess that's 1, that's a negative 1 over here. It means that it crosses through there as well. Alright, now you guys know that I could try again and see if negative 1 is a double root. However, we've talked and discussed at length about how once you have 3 numbers in your lineup, you should stop and solve using conventional methods. Why do I say that? Well, because as soon as you have 3 numbers in your lineup, you actually have a quadratic. And by conventional methods, I mean either, in this particular case, setting it equal to 0 and just square rooting. Or you could factor, right, if you have a very perfect quadratic trinomial that you could factor. Or if worst comes to worst, you could plug it into the quadratic formula. Oh, negative b plus or minus the square root of b squared. Right? If it's something really ugly. But in this case, you actually can move that 3 over. And you can square root both sides. And you know that whenever you square root, you always end up with a plus or a minus answer. And so, you end up with plus or minus square root of 3. Now, please don't be confused. This is a plus square root of 3 as one answer, and a minus square root of 3 as a different answer, which means you have now found 1, 2, 3, 4 answers. Your original polynomial was a to the 4th degree, so that means that you have found all of them, right? Gotta catch them all. So, what is your final answer? Wherever it says roots, and a big blank on your test, what you're going to do is you're going to say, well, x equaled 1, right? 1 worked. X equaled, well, it didn't equal 1 again, but it did equal negative 1. And then we had that plus root 3, and we also had a minus root 3. So there are all of your roots to this polynomial function. Okay, good luck!